This presentation covers Chapter 9, Force and Laws of Motion from the CBSE Class 9 Physics curriculum, describing force balanced and unbalanced forces first law of motion, inertia and mass second law of motion, third law of motion conservation of momentum, describing force. Force is an external effort which may move a body at rest, stop a moving body, change the speed of a moving body, change the direction of a moving body, change the shape and size of a body. Balanced and unbalanced forces, balanced forces. If two equal forces act in opposite directions, the resultant force is zero. Balanced forces cannot change the state of rest or motion. Unbalanced forces. If one force is greater than the other, the resultant force is not zero. Unbalanced forces change the state of rest or motion. First law of motion. Force of friction opposes the motion of an object. Example: a rolling ball slows down due to friction. An object in uniform motion continues moving if forces are balanced. If an unbalanced force acts, speed or direction changes. If the unbalanced force is removed, the object continues with the speed it had. Galileo's experiment. A marble rolling down an inclined plane gains speed. It loses speed when going up another incline. If the second incline is horizontal, the marble would roll forever. No force is needed to sustain uniform motion. Force is only needed to change motion. Newton's first law of motion. An object remains at rest or in uniform motion unless acted upon by an external force. Inertia. The tendency of objects to resist change in their state. Examples: striker hitting coins. Lowest coin moves, others fall due to inertia of rest. Flicking a card under a coin. Coin falls into tumbler. Sudden brake in a car. Passengers fall forward due to inertia of motion. Bus starts suddenly. Passengers fall backward due to inertia of rest. Inertia and mass. Inertia is the property of a body to resist change in its state. The force required to change the state of a heavier body is more. Mass is a measure of inertia. Momentum. Momentum equals mass times velocity, p equals mv. If a body is at rest, momentum is zero. Unit: kilogram meter per second. Example: a slow-moving truck can cause damage due to its large mass. A small bullet can cause damage due to its high velocity. Impact depends on mass and velocity. Second law of motion. The rate of change of momentum is proportional to the applied force. Mathematical form. Initial momentum equals mu. Final momentum equals mv. Change in momentum equals m open parenthesis v minus u close parenthesis. Rate of change equals m open parenthesis v minus u close parenthesis divided by t force F equals m, a unit of force. Newton. An example. 9.1. A force acts on a 5 kg object for 2 seconds. Velocity increases from 3 meters per second to 7 meters per second. Find force. F equals m times v minus u divided by t equals 5 times 7 minus 3 divided by 2 equals 10 newtons. If force acts for 5 seconds, find final velocity. V equals u plus ft divided by m equals 3 plus 10 times 5 divided by 5 equals 13 meters per second. Example 9.2, which requires greater force. Accelerating 2 kilograms at 5 meters per second squared or 4 kilograms at 2 meters per second squared. F1 equals 2 times 5 equals 10 newtons. F2 equals 4 times 2 equals 8 newtons. 8 n. So accelerating 2 kilograms at 5 meters per second squared requires greater force. A car moving at 108 kilometers per hour stops in 4 seconds. Mass equals 1000 kilograms. Find braking force. Convert speed. 108 kilometers per hour equals 30 meters per second. F equals m times v minus u divided by t equals 1000 times 0 minus 30 divided by 4 equals minus 7500 newtons. Negative sign means force opposes motion. A 5n force gives mass m1 an acceleration of 10 meters per second squared and m2 an acceleration of 20 meters per second squared. Find acceleration if both masses are tied together. m1 equals f divided by a 1 equals 5 divided by 10 equals 0.5 kilograms. M2 equals 5 divided by 20 equals 0.25 kilograms. 0.25 kilograms. Total mass equals 0.75 kilograms. Acceleration A equals F divided by M equals 5 divided by 0.75 equals 6.67 meters per second squared. A 20-gram ball slows from 20 centimeters per second to 0 in 10 seconds due to friction. Find frictional force. A equals V minus U divided by T equals 0 minus 20 divided by 10 equals minus 2 centimeters per second squared equals minus 0.02 meters per second squared. F equals MA equals 20 divided by 1000 times minus 0.02 equals minus 0.0004. N negative sign means force opposes motion. Third law of motion. To every action there is an equal and opposite reaction. They act on two different bodies. Experiment. Two spring balances show equal readings when pulled. Force by A on B equals force by B on A. Examples of action and reaction. Firing a bullet, gun recoils backward. Jumping from a boat, sailor moves forward. Conservation of momentum. Total momentum before collision equals total momentum after collision if no unbalanced force. Two balls A and B collide. Momentum before MAUA plus MBUB momentum. After MAVA plus MBVB change in momentum. For ball A, MA, VA minus UA. For ball B, MB, VB minus UB. Force FAB equals minus FBA. So MAUA plus MBUB equals MAVA plus MBVB. Momentum is conserved. A 20-gram bullet is fired at 150 meters per second from a 2-kilogram pistol. Find recoil velocity of pistol. Total momentum before firing equals 0. Total momentum after equals open parenthesis 0.02 times 150 close parenthesis plus open parenthesis 2 times V close parenthesis equals 3 plus 2 V. So 3 plus 2 V equals 0. V equals minus 1.5 meters per second. Pistol recoils at 1.5 meters per second opposite to bullet. A 40-kilogram girl jumps at 5 meters per second onto a stationary 3-kilogram cart. Find final velocity. Total momentum before equals 40 times 5 plus 3 times 0 equals 200 kilograms meters per second. Total momentum after equals 40 plus 3 times V equals 43 V. So 43 VE equals 200. V equals 4.65 meters per second. They move at 4.65 meters per second in the direction of the jump. Two hockey players, 60 kilograms at 5 meters per second and 55 kilograms at 6 meters per second, collide and entangle. Find final velocity and direction. Total momentum before equals 60 times 5 plus 55 times minus 6 equals 300 minus 330 equals minus 30 kilograms meters per second. Total momentum after equals 60 plus 55 times V equals 115 V. So 115 V equals minus 30. V equals minus 0.26 meters per second. They move at 0.26 meters per second from right to left. Thank you for learning with us.